In lesson 8.3, we're going to be talking about the division properties of exponents. So far in chapter 8, what we've done is we've done multiplication properties of exponents, and we've done negative and zero exponents. So today we're going to talk about what happens when I have a problem that's divided. Okay? Well, if you look at these problems right here, it's called the quotient of powers property, and that's just a big fancy name for saying that anytime I have the same bases, so same bases are the number that is the larger number of the problem, so it would be like your sixes right here, that if as long as they're the same and they're being divided, we can just subtract their exponents, okay? So if I have 6 to the 5th power divided by 6 to the 4th power, I can say, okay, do I have like bases? Yes, it's 6. And I can just take their exponents and subtract them. So 5 minus 4, to simplify it down to one problem. And that's going to be 6 to the 1st power. Then I simplify, which 6 to the 1st power is just 6. Okay? So that's what we do whenever we have like bases that are being divided. So then the next problem that I have is 9 to the 10th power divided by 9 to the 7th power. And I notice there that I do have like bases. My base is 9, so I can subtract the exponents. 10 minus 7 is 9 to the 3rd power. So this is when I would get out my calculator and I would do 9 to the 3rd power, which is 729. Now make sure that you remember, I am not teaching you how to plug in exponents to your calculator. I do not want you to go back and see that this is the original problem and you to say, okay, 9 to the 10th power is this number right here, which is 3,486,784,401, and you're going to say, okay, I'm going to divide that by 9 to the 7th power, and I get 4,782,969, and then you just do the division in your calculator, and you tell me, oh, it's 729. Yes, I realize that you get the same answer, but a first grader can plug in the exponents to a calculator. I am teaching you the rules, and that's what you will be tested and quizzed on, is the rules. So make sure that you know when I have the same bases and they're being divided, that we just subtract their exponents. So we do not want to see any problems like that, okay? Now, next one. I have x to the 3rd power divided by x to the 8th. And I realize, okay, I have the same bases, which is x, and I'm going to do 3 minus 8. Well, what's 3 minus 8? Negative 5. And I say, okay, time out. We learned yesterday that when I have a negative exponent, I can never have that in my final answer. So what I'm going to do is I'm going to put this problem over 1, and in order to make the exponent a positive, we have to take it from where it is in the fraction and move it to the other side. Remember, cross the line, change the sign. So what goes up top whenever I move something or everything out of the numerator is a 1, and then it's going to become x to the positive 5th power. And that would be my answer there. Okay, let's do one more. My bases are the same. It's y, and I can subtract 5 minus 1, which is y to the 4th power. Now, obviously, on the ones that we started off with right here, we never want to leave our answer with an exponent if it's a number, okay? 6 to the 1st power needs to be simplified to 6. 9 to the 3rd power needs to be simplified to 729. But when you have letters, like we did in the next two problems, we can't simplify that any farther. I mean, I could go as far as to writing out x 5 different times, but then the whole point of using an exponent goes away because the exponent's supposed to help you make it shorter, okay? So simplify as much as possible. So the next thing that we're going to do is called power of a quotient property. But you guys are already familiar with this because we've done this before. Anytime I have an exponent on the outside of parentheses, what I do is I am going to just distribute the exponent to every base. Well, I look and I say, okay, I have a base here and a base here. So 2 squared over 2 to the third power. And I ask myself, okay, can I subtract 2 minus 3 now? No, because are these like bases? No, they're not. So in this instance, we would actually just simplify. 2 squared is 4. 3 to the third power is 27. And this is my final answer here. Okay, we're going to do the same thing to the next problem. So I distribute my exponent that's on the outside, negative 3 to the third power over y to the third power. Remember, what do I need in my calculator around my base when it's negative? Parentheses, don't forget that. So negative 3 to the third power is negative 27. And y to the third power just remains y to the third power because it can't be simplified any farther. Okay, next problem here. I have a negative exponent. I still want to distribute it. 7 to the negative third power over 4 to the negative third power. Now, I can't leave this as my final answer because, number one, it can't be simplified like it is, and number two, I have a negative exponent. So in order to make an exponent a positive, we just take wherever the negative exponent is with its base and move it to the other part of the fraction. So 7 to the negative third is in the numerator, so I'm going to move it to the denominator. 4 to the negative third is in the denominator, so I move it to the numerator. Cross the line, change the sign. So 4 to the third power, 7 to the third power. Because they're not like bases, they are the same exponent, but they're not the same bases, I cannot subtract them. So I'm just going to plug in my calculator. 4 to the third power is 64, and 7 to the third power is 343. So this would be my final answer here. So now what we're going to start doing is we're going to start taking the rules that we have learned in 8.1 and 8.2 and applying them, well, as well as today's rules, applying them to problems that we have to do multi-steps in. So I look at this problem right here, and I notice I have all of the same base. The base is 3 here. Now, in order to simplify this problem, what I want to do first is I want to focus on my numerator, because I notice that 3 to the third power times 3 to the fifth power, I can add the exponents. And I'm going to simplify this because my base is the same, so it's 3. And then 3 plus 5 is 8. So I have 3 to the 8th power over 3 to the 7th power. Now I can use what we learned today, the quotient property, and I can subtract their exponents because they have the same base, which is 3. 8 minus 7 is 1. 3 to the first power is 3. Okay? Again, I do not want you to plug in each of these powers to your calculator and tell me what the answer is, because that's not the rules. That's just being able to plug it in your calculator. I want you to know the exponent rules. Okay? Let's do the same thing to the next problem. So I look and I realize, okay, I've got multiplication up top, so I can simplify by adding the exponents. My base is x, 2 plus 5 is 7, over x to the 9th power. And then I realize, okay, I have the same bases and they're being divided, so I subtract their exponents. But what is 7 minus 9? Negative 2, okay? I realize, wait, I cannot have a negative number or negative exponent. So what I'm going to do is I need to make this a fraction, and then wherever the negative exponent is in the fraction, I just move it to the other side, so it's going to be 1 over x squared. And now we're going to go a step farther, and we are going to use multiple properties. So on that one, we just used our addition and then our subtraction, and now we're going to simplify using multi-properties. So I look at this first problem right here, and I notice it looks pretty scary. So my job is to try to make it as simple as possible, okay? I want to simplify this problem as much as I possibly can. And I notice it is a multiplication problem. Yes, I have a division bar. Yes, I'm going to eventually do division. But right now, I want to focus on the multiplication part of it. So I'm going to take everything in my numerator that I have, because I know 3x cubed y is being multiplied times 12x squared y squared. So I look and I say, okay, let's work with our constants or our whole numbers first. So I have 3 times 12. Can we do 3 times 12? Sure. 3 times 12 is 36. And now, let's focus on our x's. I have an x here with an exponent, an x here with an exponent, and they're being multiplied, so a shortcut tells me I can add their exponents. 3 plus 2 is 5, so it's going to be x to the 5th power. Now, I'm going to do the same thing, but with the y's. But what is this first y's exponent? 1. Even though I don't see it, I do know it's there. Plus 2 is y to the 3rd power. Now, let's simplify the denominator of this fraction because it's the same thing. And I want to ask myself, okay, does 4 have anything to multiply with? Nope, so I just write 4. Does this x have anything to simplify with? No, so I just write x. Does my y have anything to simplify with? Nope, so I just write y to the 3rd. So now things look a little bit easier because I went from having 2 fractions to 1, and now I can simply divide and use my quotient properties and simplify. So let's start with our whole numbers. What's 36 divided by 4? 9. Now, I'm going to take and I'm going to look at my x's. I've got x to the 5th power over x. Now, what is this x's exponent right here? An understood 1. So I subtract 5 minus 1 is x to the 4th power. And now I'm going to look at my y's. And I notice it's y to the 3rd over y to the 3rd. So I say same basis, I can subtract. What's 3 minus 3? 0. Well, what's y to the 0 power? 1. Or basically what we can say here is those just cancel out. They go away. So my answer is 9x to the 4th power. So we simplified that problem that looked very huge and scary into a very simple answer. Okay? Now let's look at this next problem here. What do you think we want to do first? Distributive property. Okay? We always want to do, anytime you see an exponent on the outside of parentheses, we must distribute it. And we must distribute it to every single base we have. So I look and I have 1, 2, 3 bases. So I say, okay, here, here, and here. So I'm going to have 3 to the 3rd power, x to the 6th power, because I multiply when I do distributive, and y to the 3rd. Now, out of this problem, what is the only thing that can be simplified? 3 to the 3rd power. 3 to the 3rd power is 27, x to the 6th power, y to the 3rd power. Now, I cannot subtract these exponents right here because they do not have like bases. So, this is my final answer. Okay? Last one that we're going to do is what happens when I see a negative exponent. Okay? It's going to get a little bit trickier, but nothing that you haven't seen before. We're just putting our multiple properties and doing them step by step into one problem. So like I just said in the last problem that we did, anytime you see a number on the outside of parentheses, we always want to distribute it. Okay, and I'm going to distribute it to every single base that's in this problem. So I distribute it to this base and this one. So I'm just going to rewrite this first problem right here. Y squared over x to the negative 3rd power times, and now I'm going to write this, y to the negative 3rd power over x to the negative 12th power. Okay, now it's time to fix our negatives because I realize, okay, this cannot be correct. I cannot go on from this without fixing these. So I noticed, okay, this is negative. Is the y squared negative? No. So I cannot touch this problem. It has to stay, or I can't touch this y squared. It has to stay where it is. The x to the negative 3rd power is going to move up. So now I'm going to have y squared x to the positive 3rd power, and I can write it over 1 if I want, or I don't have to write it as a fraction at all, because anytime you take everything away from a part of a fraction, we're left with a 1. Now on this problem, I know in order to get this 3 to become a positive, it needs to go to the bottom. This 12 to become a positive, it needs to go to the top. So I just rewrite it x to the 12th power over y to the 3rd power. Okay, now I'm going to do what we did in that first problem on the last example, and we're going to work straight across. So we're going to find like bases and add their exponents. So I notice I have x's here. So 3 plus 12 is x to the 15th power. Does y have a like base up top? No, it does not. So we leave it y squared. Say, wait a second, it was yx, but you wrote it xy. It's okay. It does not matter what order they're in. Now, on the bottom, I just say keep y to the 3rd. Now, what can be simplified here? Y squared divided by y to the 3rd power. I can subtract their exponents, and I'm going to keep x to the 15th. 2 minus 3 is negative 1. Now, can I have a negative 1? No. So what I'm going to do is I'm going to take and I'm going to move this y down to the bottom. And finally, I get my answer as x to the 15th, y to the 1st power. Now, you don't really have to write this little 1 right here. You can leave it as y because we know that the 1 is understood, but you can if you want. Okay? So this is how we simplify using all of the properties that we have learned. Here is the homework for 8.3. It's page 466, 20 through 48 evens.